Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Yes, students, today we talk about the post-order traversal. We are done with the pre-order traversal and now we have the post-order traversal. This pre or post is about the root. Okay, in pre-order we first traverse the root because we had the pre, and now in the post basically we traverse the root in the end. So that means we're gonna recursively traverse the left subtree, then right subtree, and then in the end root. So if we have got, for example, A, B, and C, in the pre-order, pre was saying that access the root first. Now post is saying access the root at the end. First go for the left subtree, then go for the right subtree, and then the A. So that means this will be like B, then C, then A. In pre-order it was like first A, then go to the B, and then C. Right now here we are saying post order. That means A will be post of what? Left and right subtree. In fact, if it is a tree itself, so we have to first access all that left subtree. If the C is also a subtree and what it has nodes attached, we have to finish with all those. Then in the end we come to the A. Okay, so that's why we are saying start from the root node. Okay, now go to the leftmost node, so don't write that. Okay, you go to the root node because that's the starting point, but don't write that. Go to the leftmost node from the root node in the left subtree. Okay, when the leftmost node is reached, when that is reached, okay, write it down. So at the end, when the leftmost is reached, you will write down. Then you you go to the leftmost node's parent node, come back. So for example, we got like this is A, B, C, then there was D and E, and this was having F and G. So you go to the left and go here to the left, go here to the left. So leftmost, when you reach the F, that's the leftmost. This is this point number third. When the leftmost node is reached, so you will write it down. So you write down the F. Okay, then you come back to the parent of that leftmost node. Okay, this is here the point number 4. Visit the leftmost node's parent node, that is D. Okay, don't write it. Okay, now point 5, go to the first node of the rightmost right subtree. Then he's talking about the right subtree, but we have to first finish this thing. What actually here is we are talking about that we have when we have reached the F, then go to the first node of the right subtree and do same thing what we have done with the A. Okay, that means go to the left, if there is any, then go to the right, if there is any, but there is none. Okay, then you got to do what? You got to write the G. Okay, then you write the G because that is there is none left. Okay, because that is your the only node there. So when you come back, then you can write the D. Okay, now in this manner, if we talk about this node only, this subtree only, okay, we have access to the F, that's the left, then the right, then the root. Okay, now if we talk about B, now its left is done. Okay, now go to its right, that is E, and then come back to the B. Okay, then write the B. Now this same thing happened with the A. Now this its whole left subtree is done. Now go to its right, that is C, and then come back because there's nothing left, then come back to the A. So it will be like this. Post order traversal will be like this. Let's take up the examples. Let's do the post order traversal of this tree. So we are firstly at the root node. Don't write it, go to the left. It is root node, it is having the left, so don't write it, go to this left. So there is no left, so it's the leftmost, write it down, D. Now go to its parent's right, the first node, don't write it, go to its left, that is H. Okay, and go to its right now, that is I, write it down because there's nothing left, so write it down. And now go to its root, that is E. So in this node we did HIE, left, right, and root. Okay, HIE. And now in this in the node B, we are done with the left and the right. Right was this thing. Okay, we did that, HIE, and then firstly the left, then the right, and now it is the time of the root, so write the B. Same thing will happen with the A. We are done with this whole left. Okay, left is done, we got to go to the right. Okay, and in the right we move to the C. C itself is a tree, so go to its left, that is F, okay, and go to its right, that is G, and then write back C. And when you are done with the right, you are done with the left, you are done with the right, then go to the root, then A. So this is what is the post order traversal of this tree. Okay, now let us see this tree. Here we go to the A. A is having a subtree, so go to its left, go to its left, so write the E. So E, after we have to go for right of it, but it's still tree, so go to its left, that is I, write the I, okay. Then it has no right, so G, okay. Now in this case we have done the left, we have done the right, now the root. Now in this case we have done the left, okay, we have done all this left. Now go to its right. Now it itself is a tree, so go to its left, that is N. Now go to its right, it is itself a tree, go to its left, there's nothing, go to its right, that is M, and then write the K. Okay, when now we are done with the N, we are done with the right subtree of the F. Now write the F. Now come backtrack to the A now, because A has, we have done the all left of subtree of the A, all right subtree of the A. Now write the A. Now this is EIG CNM KFA. Okay, this is the post order traversal of this tree. Okay, so how we gonna implement it? Simple is we little change this our previous program of pre-order. We have the same structure for the node, and we have here in the post order the same structure. Only thing is we first call the root arrow left, then we call the root arrow right, and when we are done with left and right, then we will do root arrow num. We will print that root arrow num. Okay, if you're not getting it properly, you can watch the previous videos on the linked list presentation of the binary tree. There it is being explained properly. Okay, now this is a recursive definition. We can also have the non-recursive iterative definition. Now this is a solution for the single stack non-recursive iterative post order traversal of a tree. So what we are doing here is we will do it while our root is not null. So simply we have our pointer which is pointing to the root, and that is the first node. Okay, then what we do is we push root's right child and then root to the stack. So that means we had to push to the right child, that is F, and then A to the stack. Okay, so what we are doing is here on stack, so this is stack, and I push first the right child and then the root. Okay, this is important. We first push the right child, then the root. Okay, and P goes to P arrow left. Now P is at C. That is what it's saying, set root as a root's left child. So how we do that? P equals to P arrow left. So that will move P to the left child of the A. Okay, now we are here, and the same thing will happen. Step 2 will repeat here, because we have to repeat step 2 and 3. Step 3 is some we will apply when we pop something from the stack. So right now we are not popping anything, so step 2 is happening. So what will happen in step 2 is push its right child, that is G, and itself to the stack, and move P to the last. Okay, P arrow left. Okay, so that will move to the P is pointing to the E. Okay, these are done. So P is pointing to the E. Now here again the same thing happen, that we are gonna push the right child to the root to the stack, but it's not there, so we got to stuff E to the stack. Okay, so we're gonna stuff E to the stack. Okay, we are done here. Okay, and now P is good P arrow left, because there is null. So P at that time when there is null, we gonna pop somebody from the stack. So definitely the top of the stack, that is E, that's gonna be popped. Now when we pop, there will be two things which will happen. Okay, if I pop and the top remains this, say for instance C, if that is the right child of the E, then I gonna do A, third steps A. But if it's not so, I gonna simply print it. Now C is not the right child of the E. Okay, so therefore the B point will come up here, so we're gonna print the E. So E will be printed, so I'm printing E here. So and now when I print the E, and the pointer P will go to the P arrow left of the E, and that is null. So when there is a null, you got to pop from the stack. So E is not there, now we have a C there. Okay, now we have a C there, right? So you are popping the C is not there, so you're popping the C. And what is on the stack? That is G, and G happens to be the right of the C. So this is what we are saying here: if the popped item has a right child and the right child is at the top of the stack, because popped item was C and it has a right child, yes it has, and that happened to be the top of the stack this time, then what we got to do is we remove the right child from the stack and push root back and set root as a root's right child. Okay, so what does that mean is, in this case we do what, because what we popped, that was a C, and its right child happened to be the top of the stack. In this case what you do is you will do F, A is still there, you will pop the G, okay, and put C back in. Okay, push C back and pop the G. Okay, you will do it only if the right child is on the stack. That means that actually means that we have not traversed that. Okay, if we would have traversed that, for example, and we are backtracking, at that time it would not have been there. I will tell you in a moment that thing. Now our P, the pointer, will point to the G. So that's what our root is, because P is pointing to the root. So this time our root is G. So P is now pointing to the G. And same thing will happen, that we're going to push the right child and the G onto the stack. Okay, but there is no right child, so we're going to push G back on a stack, and now put pointer P to the P arrow left, that is P is pointing to the I. Now same thing will happen to it. I will push I here, because it has no right, it has no left. Now P is for P arrow left. Now that is the P arrow left is null, so at that time I'm gonna pop I, and when I pop I will see that step A, what is on the top G, is that it's right? No, it is not. So it will happen, B will come into play. That means we will print the I. Now I is gone. So when I is gone, P will point to the top of the stack, that is G. Okay, I pop the G. When I pop the G, what is on the top C, is that it's right? No. So that means I'm gonna print it. So I'm gonna print the G. So I'm printing E, then I print I, then I print G, right? Now P will point to the top of the stack, that is C. So you pop the C. Okay, you pop the C. Now when you pop the C, what is on the top of the stack? A. Is that its right child? No. So you simply print it. So print the C. Now this much is done. Now we have only F and A on a stack. Okay, now pop A. Now A will be popped, so A is no more. Now we are gonna pop A. That means when you pop A, that is P is pointing to the A. Now we are back here, P is pointing to the A. So when you pop the A and the right child F is on the top of the stack, yes it is. So step A will come into play. What we do is here we pop the F and we push A back. So we have A on a stack and P is pointing to the F. Now P is pointing to the F. Okay, and same thing we apply with the F. That what we do, it has a right child, yes it has. Now push the right child onto the stack. So stack will be like this: A, then back the F. Okay, sorry, I was here. You got to push first the right child, that's K, and then the root, that is F this time. Okay, onto the stack, and P moves to the P arrow left, that is N. Now P is pointing to the N. Okay, now there is no left, no right, so you can push it on there. Okay, on the stack, and now P arrow left, there is null. So in that case you will pop the N, and what is left is F on the stack. F is not its right child, so you're gonna print it. Step B. Okay, so and P, when you print the N, you are actually popping after that, that is the F. Now you pop the F. When you pop the F, what is on a stack? K. That happened to be the right of the child. So in that case, what we do the step A. What you do in that, you simply pop the K and push back F. So we have the steps like this. Okay, we will push back F and pop the K. Now that means our P is pointing to the K. Now in this case there is no left, but there is right, so you push back the M and you push back the K. onto the stack. Okay, and p is going to p arrow left, that is null. So when you have a null, pop the pop from the stack, that is k. Okay, so when I pop the k, okay, and when you pop the k, and there is left out is m. So m happens to be the right child of this. So in this case what you do is you push back k, so af, you push back k and pop the m. Okay, step a of 3. Now when you pop the m, okay, now you see it has no left, no right. Okay, uh, in this case when you pop the m, and there is what's left out is k, that is not this right, so you're going to print it. Okay, and now our pointer will point to the top of the stack, that is k. Again you pop it. Okay, you pop the k. What is on the top of the stack? F. Is that its right child? No, so you're going to print it. And now you pop the f. Okay, when you pop the f, there is no more this thing. And what is left on top, what is on the top? A. Is it its right? No, so you're going to print f. And similarly you're going to print a. So this is our post order traversal uh, of this tree using the single stack. Okay, so we have very simple steps here. You push first the right child and then the root. Okay, and move root to the left node. And then when you are at the end, there is null. What you do is you pop something from the stack, and when you pop from the stack, you check if it is right child is on the stack. Okay, in this case, for example, here in the end, for example, I was popping the f and a was there, so it doesn't have a right child on it. That means we have traversed its right. That means these guys are being traversed, so we should not be worrying about them. So that is why we are not pushing its right child there. Okay, so if k or f would have been there, that means they were not traversed yet. Okay, so in this manner, let's do another example to understand properly. Or this is your assignment, just try this algorithm on this tree. Okay, okay, so this is the end of the segment, and see you in the next lecture.